Alright, here's another video for chapter 3, and I think some of the portion I had already sent the explanation regarding with the square root, and others. So here I'm going to explain a little bit about the exercise. Now the first question, I'm going with question number 2. It says like this: find the square of each of the following numbers without the actual multiplication. That means you have to apply a certain any method, but not by multiply. So in this case, what we can do is, we have this method by applying the identities. In this particular question, we have to apply by these identities. If you remember, we have many identities, but in this case we apply with a plus b holding square, so which is equal to a plus b into a plus b. Okay, so these are the identities which we apply in this question number 2. But we have many identities like a minus b holding square, and then we have a minus b holding a minus b holding square. We have a minus b, and then we have a square plus b square, and so on. We have many identities, but in this case, like I said, we have to apply with this the easy one. Okay, so in this case we have 3-4 steps that we have to simplify in order to get the final answer. So the first step is 76 square. Now make sure that you know the difference between the square and the square root. Now in this chapter we will learn how to find the square and the square root with different method. Okay, let us jump to this question number E, 76. This 76 square, since we have to find for the square, okay, for the square of this 76, so we apply by this formula a plus b holding square. So which means that this 70 plus 6, we just modify from this 76, because if you add 70 plus 6, you'll get back to 76, but we need to modify in order to get the identity. Now we won't go back, we have to proceed forward. Now the next step is we split this square, because if you have for example, if you have this x square, then you can write into two parts. Since we have power 2, we can split them. Now the same thing, we can write 70 plus 6 into 70 plus 6, but between them there is a multiply, like there is a multiply here between these two x. Now this bracket, I don't put the multiply sign, but you should know that the bracket represents the multiply. Now next step is I'll multiply this first term with this 70 plus 6. This 70 now multiply with 70 plus 6, and then next is you add this plus 6, then this plus 6 you have to multiply again with this 70 plus 6. So next step is you just multiply 70 into 70, you'll get 490, plus into plus, you'll get plus. Now remember, when you multiply, you have to multiply along the sign with plus minus. So 70 into 6, you'll get 420. Now next is plus into plus. In front of 70 there is a plus sign, though we don't write, but remember there is a plus sign since there is no minus. Now plus into plus, we get plus 6 into 70, we get 420. Then next is plus into plus, we get plus 6 into 6, we get 36. Now between all this number there is a plus sign, so we need to add all these four numbers: 409, 4900, 420, 420 plus 36. Now after you add in your rough work, you get 5776. Okay, so this is these are the steps that we need to do in order to obtain the square of any number, without actual multiplication. And if you want to perform the with multiplication, if you multiply 76 into 76 also, you get the same answer, that is 5776. Now I'll jump with next question. Question number 3. Now I'll jump to question number 3. Write the ones digit in the square of each of the following numbers. Now the square again, we have the square, but it doesn't mention by which method that we have to find the square. But we apply in this case. I'll show you with the multiplication method. So for this 13, since it says the square of each of the following numbers, that means we have to multiply twice. Okay, twice. But I don't want to show like the question number 2, 13 square, like this. I don't want to show, but you must know that when it says the square of any numbers means 13 holding square. This square here, it means the power 2. So in my rough work, I show you how to multiply directly 13 into 13. 13 to 13. Now the question here is want us to find for the ones digit in the square. That means after we multiply twice, 2 times for any number, like here it is given 13, and then in your rough work you multiply twice 13 into 13, so you get 169. Now if you remember, to find for the ones digit, if you remember the Indian place value chart or international, we can go for Indian place value chart. Ones, tens, hundreds, thousand, 10,000, and so on. Those are the place value chart. Now for the ones digit in this case, we have, after we multiply twice for 13 to 13, we get 169. So starting from the back number, then we have here 9. So this 9 will be the ones digit in the square of 13. It will be the ones digit in the square of 13. So this is it. For this one, we just have to find, after we multiply twice for all the number, then you pick the ones digit of its total. Okay, now we have the, if you could remember, let me show you from your textbook. Yes, this is on page 34. On page 34, that this is just a kind of trick to remember without multiplying. If you can remember all this 1, 2, 3, 4, 5, 6, all these 6 steps, the 6 point, then you can directly know which one the digits, which digits will end after you multiply twice of any number. So the first point is that if a number ends with 1 or 9, its squares ends with the digit 1. And if a number ends with 2 or 8, its square ends with the digit 4. If a number ends with 3 or 7, its square ends with the digit 9. If a number ends with 4 or 6, its square ends with the digit 6. If a number ends with 5, its square also ends with the digit 5. If a number ends with 0, its square also ends with 0. So that means here the number 13. So the number 13, so 3 is the last number, or the end of the number is 3. Then its square in its one digit, it ends with 9. Okay, so 3 here is given number 13, and 3 is the last number. And then after you multiply, the last number that will act as your one digit, it will be 9. The same thing with the rest of the number. You can apply by having this 6-7 points. Alright, now let us jump with question number 5. Question number 5. Express the following as a sum of consecutive odd numbers. We have to, what is given here is the 10 square. It is already given you in terms of power 2. So we have to find this 10 square without multiplying, again without multiplying, but by applying this consecutive odd numbers. So that means we have to plus all this number until and unless we get the square of the this of given number. So we have here 10. So actually the number 10, the square of 10, it is 100. But we won't multiply, we won't do this method by applying the multiplication method, but we have to apply by adding all the odd numbers. I hope you know what is odd numbers. It is the numbers that we cannot divide by 2. Numbers that we cannot divide by 2. So it is 1, 3, 5, 7, 9, 11, 13 plus 15 plus 17 plus 19. So after you add all these numbers, you'll get 100. Now the same thing with the rest of the numbers. Question 7 is, which of these are Pythagorean triplets? Number A, it is 5, 10 and 12. Now what is a Pythagorean triplets? I think last time I had sent regarding with the Pythagorean triplets. So Pythagoras triplets, it talks about the side of a triangle, whereas Pythagorean triplets, it talks about the numbers. Okay, about any numbers. I'm going to say it talks about the constant. It is the constant or the exact value. Pythagorean triplets. In this Pythagorean triplets, let me show you with its yes, here it is, page 37. On page 37 it says like this: Pythagorean triplets. If the sum of the square of two numbers is equal to the square of a third number, then the three numbers form a Pythagorean triplets. Now we have three numbers. So if you add any two of the numbers, then it must equal to the square of any to the square of the third number. That is the statement. And also we need this expression. In the next question we will use this one, that by having this Pythagorean triplets, we have this equation twice m square plus m square minus 1 square, it is equal to m square plus 1 holding square. Now we will apply this equation of Pythagorean triplets. So in this case, we will put the third number as 12 on the right side, and then the two smallest number, we can put it on the left side. So from the Pythagorean triplets, we must put the square. So because it says that the square of the two numbers must equal to the square of the third number. So from there we have to multiply this 5, add this two smaller number on the left side, we'll get 25 plus 100, and then 12 to 12 we get 144. Then after we add on the left side, we get 125, and then the third number is 144 after we multiply with the 12 square. So since the left hand side, since 125 is not equal to 144, so the given numbers, that is 5, 10, 12, does not form a Pythagorean triplets. Okay, now to know which of the numbers form a Pythagorean triplets, we must use these steps. We must show that the left hand side must equal to the right hand side. If left hand side is equal to the right hand side, after we simplify, okay, after we multiply, after we add on the left side. After and then if it is equal, if left hand side equal to the right hand side, then the given numbers form a Pythagorean triplets. Alright, now the next question is question number 8. Question number 8. Find a Pythagorean triplet whose greatest member is 17. Now we have for the Pythagorean triplets, remember we have to find for three numbers. Now one number is given, that is the greatest member is 17. So we have to find for the other two number. So in this case, the greatest member, if you follow from those equation of Pythagorean triplets, m squared plus 1, it is the greater number. And then what is given here is greatest member is 17. So m squared plus 1, it must equal to 17. Now you simplify for this equation, m squared plus 1 carry to the right side, you will get 17 minus 1, and then you simplify this, you get 16. Then carry this power 2 from m to the right side, it will convert to square root. So the square root of 16, it will be 4. Now if you follow from those equation, to find for the other two, we have to use those equation, but without the square. Now if you check from your textbook, Pythagorean triplets, we have the square. In this equation we have the square, but since we have to find for a number, neglect the square and take only twice m square minus 1 and m square plus 1. So use this equation, twice m equal to, in place of m you put 4, then you multiply 2 into 4, you get 8. Now next number, it is m square minus 1. M square minus 1, it is m is 4. Since we have power 2, so we need to multiply this, we need to put power out of the bracket, so that we need to multiply. When you substitute for m, you please put with a bracket, so that in the next step you need to multiply this 4 twice, and you'll get 16 minus 1, and then after you minus, you get 15. Now the same thing with this m square plus 1, you put in place of m, you put 4 holding square plus 1 equal to 16 plus 1, you get 17. So these are all the Pythagorean triplets. So therefore the required Pythagorean triplet is 8, 15 and 17, which is given. 17 is given from the question. Now for question number 9, it is similar to question number 8. The only thing is different here is the given. The given here, it is in terms of the smallest member. Now for question number 8, it is in terms of greatest member, whereas here it is the smallest member. The smallest member, it is represented by twice m. So this twice m must equal to 22. That is a condition from the question that the smallest member is 22. So again, you must simplify this twice m. If you remember, we take it from the Pythagorean triplets. Okay, you must remember the Pythagorean triplets and its equation. Twice m is equal to 22, and then you simplify, carry this 2 to the right side, you'll get it as, it will act as a denominator, because it is a multiply between twice and m. There is a multiply sign between them. So since it is a multiply, so when you carry to the other side, it will convert to divide. So okay, now next step is you divide 22 by 2, you'll get 11. Now the same thing as question number 8, you follow those, you pick for this from equation from Pythagorean triplets. Twice m, in place of m you put 11. So since this twice m, you can check from this first step, it is already equal to 22, so you need not multiply, or you need not put the value of m. Even if you put like question number 8, it is your answer is correct. Now next is m square minus 1, then you multiply, then you get 1 to 1, minus 1, you get 120. M square plus 1, 11 into 2, So we get the required Pythagorean triplet is 22, 1, 2, 0, 1, 2, 2. Now if you look, 22 is the smallest member. So it is 22, and the biggest number is m square plus 1, which is 1, 2,